The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. There's a YouTube channel out there called John's Arcade about a guy with a bunch of arcade games in his basement, and he recently asked us if we could help him with a project. Let's call him up on Skype and see what he needs.
Amazing hacks.
How can we make this portable?
Inspired designs.
I am the internet troll.
Regrettable acting.
Batten down the hatches!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Ben, the purpose of our call is this. So you and I were talking for a short while about trying to find a project to do together. And we were talking about maybe you making something for me, but then I got this email, this viewer mail, because I do viewer mail on my show, and it's from a viewer named Erie, okay? And Erie sends me this email. He says, John, I am an arm amputee, and I'm looking for a bit of advice. He says, I shudder at the thought of putting a flight stick on any of my games in place of a joystick, but I want to play the games in my collection. Having one arm, I cannot hit the buttons and work the joystick at the same time. Do you have any alternatives for joystick button combos that would take the place of like a Xenophobe or Tron style flight stick? So, well, when I read this email on my show, I immediately thought, Ben's doing this kind of stuff all the time. Because you made a one-handed pinball controller not that long ago.
Yeah, with the pinball, it was a guy who plays in tournaments, and he would drill additional buttons into his own games, but you can't do that on location or at your friend's house. So yeah, we made him a solution that kind of suction cupped onto an existing game and duplicated the buttons for him. So you're thinking we should do that, but for arcades?
I think so, Ben. What do you think? Is it possible? Some kind of a device that he can like put in his backpack and go to an arcade and just start playing.
Yeah, so what we could do is we could make a joystick add-on that has the buttons that you want, and then it would be non-destructive. It could just use weights or clamps or suction cups. But yeah, you have those multiple games in the background, so what you could do to help is get some measurements of like the joysticks, the shafts, the buttons, so we have an average.
Sure.
Yeah.
Yeah, I've got about 40 games I can measure.
Oh, awesome. By looking at that, we can find the similarities between them and figure out what we could build that would kind of encompass as many different games as possible. And then you're going to be at the Southern Fried Game Expo?
That's what I was going to tell you. So I told Erie about this, the person that you're making the device for, and he wants to fly to Atlanta and meet both of us at the Southern Fried Game Room Expo, because you and I are both speaking there, and it's June 19th to the 21st in Atlanta, correct?
That sounds right.
So Erie is going to come there, and I thought it'd be awesome if you have the time to bring the device if it's ready, and Erie can try it out on their arcade games.
Yeah, I mean, that sounds like a great way to conclude this episode, and there'll be plenty of games to try. So yeah, get me those measurements of joysticks and buttons, and then I'll design something, and then we'll meet at the Southern Fried Game Expo.
Ben, that sounds like an awesome plan. I'll see you in June.
Nice. The John's Arcade Accessibility Project is about finding a way for someone with only their left hand to play arcade games that require two hands, joystick and action buttons. So what I think we'll do is we'll make some sort of cover for the joystick, something that clamps on over a standard arcade joystick and adds two buttons, almost like Xenophobe or Tron. Basically puts the action buttons on the joystick instead of beside the joystick. Those action buttons can control a button actuator, which we'll have to design, that will fit over the standard buttons and push them for you. The whole thing will look like this: battery pack, joystick cover, or possibly a glove, and the button actuators. The thing that might work about a glove is instead of having to make something that clamps onto every size joystick, you can just make one glove that fits like a glove, put it on, and the clickers would be attached to your fingers, and it doesn't matter what kind of joystick you're holding. So we'll have to see what method works best. We will start by building the button actuators, because that part should be simple. All it has to do is push a button, right? I don't have any arcade games anymore, so I laser cut this test rig that has two buttons on it in pretty close proximity. So we use that as the baseline. And the test rig also sits at 10 degrees to simulate the slope of an arcade machine. And I'm using these snap action switch buttons. These are actually more modern. This is like a 1990 and newer kind of thing. Older machines would actually have a leaf switch underneath. But if our mechanism can push these stiff switches, it will definitely push any other kind of switch you put it up against. So this is our worst case baseline. We have these solenoids left over from the mini pinball project. I'm thinking these might be a good bet to actuate this. What we can do is we can make some sort of enclosure that fits over the button, and then this will have an armature that will go around the solenoid and push down on the button, and there'll be a spring to hold it up. Okay, we're gonna do most of this from a side view. Here are the buttons, and we wanna have something that fits around the button but has a little bit of a, slop. That's represented by these gray pieces here. We'll probably print that out of some sort of rubberized material so it has a bit of a grip to it. The solenoid side view will look like that. I've drawn in the 2 positions of the rod. It moves about 3/8 of an inch. Around that, we'll have an actuator. It'll probably be a little bit more streamlined than this, but basically this moves up and down with the solenoid and pushes the button for you, like that. Put an enclosure around it. Again, we have to keep the enclosure somewhat small so we can fit them side by side. This is probably about as close as we can get them. And I will draw the enclosure actually from a couple different angles, including the top. And this area here is going to be a weight area. We'll get to that later. Let's take a look at the 3D file. Here is our rubber base. We'll extrude it up and it will look like this. So I think I'll print this out of Ninja Flex. This is the part that actually hugs the button. See how there's a cavity underneath it? That's will fit the curvature of the button. So the button will fit up into that. And then we'll glue the plastic case onto this. And I'm using rubber so that it will kind of have some inherent friction or stickiness on the machine and not slide around. Hopefully not slide around. We also have to think about the weight. I mean, the force of pushing this button down will cause an equal force to push up, which means we're probably gonna have to artificially weight whatever we build. So here's the first design I came up with. Actually, let's go into outline view. Okay. All right, so it has a little bit of area here for some artificial weight. And on the inside, we have some mounting points by the cursor there for the solenoid. This is obviously the side view. Let's switch this. And there's a hole here for the power wire to escape. And there's slots in it which will allow the actuator to slide up and down and not get bound up. My test buttons are hooked up to the multimeter, so it'll beep when it's pressed correctly. Here is the actuator I made for the solenoid. So you put a spring over it like this, and then you put this into the actuator, and there's actually a notch so it only fits in one direction. And what'll happen is this will actuate around the solenoid. All right, now here is the main portion that we printed. So we put the solenoid into this, and the solenoid has some 632 size mounting holes. So let's slide this in place. There we go. And there's also blockers down here which prevent the solenoid from going past the holes either. That's the idea. So let's add at least one screw to hold the solenoid in place. And the metal frame is threaded, so this should go into the frame as long as my measurements are right. Here's the base that I printed, and it's curved on the inside to fit over the button. So the thought is we glue this to that, so we have a stiff plastic piece and a rubberized piece for grip. And then it presses the button. All right, got a drill battery left over from an old project with no drill to hook it up to, so I know we can get a lot of juice out of this puppy. Let's try it out. Uh-oh, that's odd. I think it needs a little bit of throw. It needs a little bit of distance to get up to speed before it can hit anything. So my assembly here is a little too low. I printed this spacer so we can check to see how much we need to add in order to make this work. I will put that on top of the rubber piece and try it again. Okay, so adding 0.15 inches is enough distance to give us the throw we need. So now we have to see if this thing will actually stay in place with all that force being applied. I rarely use blue painter's tape to paint. In fact, I don't think I've ever, I've used it to paint, but it's in the minority of the times. So the idea is you would be cruising in the arcade, you'd be like, hey, I'm gonna play some Street Fighter or whatever. Actually, I hope they don't play Street Fighter. I don't want to build 6 of these. Anyway, like that. But I'm wondering if this will stay in place with all that force being applied. So let's do this. Let's hook it up to the battery. Yeah, it kind of looks like that hopping boot from Mario Brothers. This doesn't weigh a whole heck of a lot. It's probably about 5 ounces. So we need to artificially weigh it. Let's try this box of drill bits. It weighs about 2.5 pounds. Well, that's certainly enough. Okay, we need to weigh this sucker down. I have designed one called Actuator Loaded for Bear. It's kind of the same thing, except for it has a much larger base, and that base is hollow. So we can fill it with something heavy, like lead. See the hollow base there? And we have it in a half circle shape, so we can still butt 2 of these right up to each other. And we just put the weight off to the side. And there's a little hole on the side of it for filling the weight. I reprinted the sleeve in this clear material that's more of an opaque, but whatever. And we're going to install our solenoid into it. Again, just temporarily. Got the 2 screw mounts, and this sleeve is a little taller too, so it'll take into account that extra space we needed for the throw. That's a little crunchy. Hey Felix, let's grind off the corners of this actuator.
You want me to just file it? Or?
Use the belt sander.
All right.
Grind it about, I don't know, 1/16 of an inch. We still need to weigh this down. It's a little better than it was. So I made this all hollow. We need some sort of lead we can pour into that hole.
Where could we get those?
Shotgun shells, yeah. I thought about using fish sinkers, you know, like when you're catching fish, but those are kind of large. Anyway, I'm going to open enough of these up to get enough pellets to fill up the base of this unit. And these are lead, so we get a nice heavy density out of them. All right, let's test it out, Felix. Fire it up.
Okay.
Oh, it's still bouncing. I wonder why that is. Try it again. Oh, maybe it's because it can go further than it needs to. See, you go down, you click, and then you can still go further. Because I wanted there to be some variance because the height of the button can be different. If the solenoid doesn't have enough power, it can't push the button, but then if you give it enough power, it has enough power to lift itself up. And we really can't make the mass of this any larger than we already have. It already weighs like a good 3/4 of a pound. What if we limited how far this can go down with some sort of set screw? And we don't have time to reprint this, but we still have to make a cap for it. Yeah, we could reprint this blue piece and embed a threaded spacer like that. And then in the cap, we could embed a flat spacer without threads on it like that. So in the cap, the size 6 screw can go up and down. We actually probably want a nylon spacer for that. So this will be sitting in a nylon spacer in the cap, and then it'll thread into a threaded insert inside the blue thing. So basically, and we'll put a knob up here so you can actually twist this and set what the farthest down distance is. Yeah, I think that's a good bet. And you can also tell what it is. You can manually push the screw in to figure out the click and then basically thread it until it's tight. That way it won't go further than that. All right, I will get to work redesigning. Here's my fix. We reprinted the blue actuator and there's a threaded post inside of it that this screw can go into. And this screw will go through the cap like that. Might need a little reaming out. The idea is this allows you to set the maximum stroke of the solenoid, and then it will be limited by this hitting the top of it. And that should hopefully keep it from popping up like it was before. Let me screw these in. and then we can try it without me holding it to see if it actually fixes the problem. I'm only gonna screw these partially in because if I screw them in all the way, then it won't work. What happened to me? I used to have reasonable fears and doubts. Then I worked with electronics for decades and became superstitious. All right, give it a shot.
Sweet.
Okay, hold on, let's make sure that that actually fixed it. Let's undo it.
Okay.
Now see if you can make it jump. All right, cool.
That's awesome.
Yeah, and you can also manually push the button if you want, for some reason. Sweet. Now we just have to make another one of these. Next, we need to think about the joystick control. So I drew a picture of my hand, just like when you make a turkey in kindergarten. And I'm thinking the ball of the joystick will be right about here. Then the two fingers, the index finger and the middle finger, will activate the two triggers. So I'm going to use that as a scale base reference. John measured all the joysticks in his arcade, and here are the results. Average of 32 millimeter diameter, maximum 38, minimum 27. So what I've done, since I don't have any arcade machines here, is I've 3D printed balls with stalks to represent the arcade sticks. Here's a bunch of pictures so I can get an idea. Some of these have kind of fat bases, see that? So I have to assume they all have that. I think Dragon's Lair actually had the widest diameter ball, so you could handle all the action. You know, I never really cared for that game, because it's not a game. Sorry, Don Bluth. Made a lot of money though. So here I have a scale reference. This game is gyrish, and I know the diameter of the ball, so I can figure out the diameter of the shaft, which is 0.65 inches approximately. So what I did then was I took that into a 3D program. I basically started with the ball shapes. There's an inner ball, which is the 27 millimeters. There's an outer ball, which is a 38 millimeters. And what I want to do is I want to have a clamp that holds them. So it'll hold up to a 38 millimeter ball, but down to a 27 millimeter ball. So I started creating extrusions that would fit around it. See how it has a curved portion? And then there's mounting points here to attach springs. So here's what that looks like. Here's one sample that I printed. And again, I'm not going to print the whole thing. I'm just going to print one sample at a time until I know it works. And it's gripping a 38 millimeter ball. So what you would do is you would remove it. And again, this isn't mounted to an arcade. Here is a 27 millimeter ball. Wow, it's so weird. I guess games are for kids, right? That would slip on, and it also fits that. See? So the front portion of this, which is right here, this will be attached to a further trigger portion for your index finger and your middle finger. And you can see that on the screen here. Basically, these lines indicate the center points of the switches for your fingers. And I'll probably model in these small switches if I know they're going to work with the voltages we need. So it'll be click, click. That's why I 3D print things one at a time. I make sure this part works before I create the rest of the design in case I have to change something, and also reduces print time. The springs might be a little too close together. They could probably be further apart this way, but you know, you can still slide the ball in and out of them, so whatever gets us the tightest fit, I think is the best. This is the latest piece I printed. I've integrated the ball grabber into the thing that you will hold here. I'm gonna attach these screws and then we'll see how it works. No one will be seated during the pulse pounding screw scene. Okay, this represents a joystick on a game, so, I'm gonna go play this game. Yeah. A real joystick ball will be a lot smoother than this thing. Oh, there we go, all right. Pew, pew. I'm the last starfighter. Yeah, that seems to work pretty well. And then when you're done, I'm gonna go play another game. Okay, I think this is a pretty good direction to go in. I'm going to, improve some of these angles, make it more smooth, to hold in the hand. But I think I will continue along this path. I glued together the two pieces from the 3D printer into one form, so it's rounded on both sides. And you grip it like this. It's for the left hand. It's got some places for your fingers to rest and a rest for your thumb as well. So yeah, let's attach the switches and the ball clamp to it. A lone astronaut crashes on a planet and there's no one there except for a single woman, but she's actually a robot. Twilight Zone's still great, even if most of the plots are like that. I don't have an arcade machine here, but I'll still simulate it. Here's a joystick. I'm gonna try to put this on with one hand. Ta-da! Smaller joystick. Cool. Now to wire it. The wiring for this is very simple. We'll send positive voltage to both of the coils. The coils will return through these two switches. I use these larger cherry switches so they'll have a higher current carrying capacity, and then that will return to ground. So basically, you close the switch, the solenoid fires. Let's go over how this thing works before the trip to Atlanta. There are solenoids that push actuators down onto the buttons. We've added these serrated rubber feet to the bottom to help keep it steady. And we made 2 of these units that are weighted. They'll sit over the buttons. These are the adjustment rods. If you recall, if these aren't adjusted correctly, it throws too far and actually causes the thing to hop. So if it's hopping, you just adjust these until it works properly. And then we're using a cordless drill battery for the power source. These actually have a lot of juice in them. Even the older nickel metal hydride ones are pretty good. Let's give it a try. So this one's a little hoppy, so we're gonna, can't remember if you dial up or down. I think down. Yeah, there we go, yeah. So you dial it until it's not hoppy anymore. All right, I think we're ready to head to Atlanta. We're here in Atlanta at the Southern Fried Game Expo. I finally got to meet John Jacobson.
Hi, Ben.
Of John's Arcade, and this is Erie High, who needs the controller that we're working on. Let's go into the room and check it out.
Let's do this.
So what did you think?
It was fantastic. Something that I'll definitely use. Very functional for me.
It's always fun to come up with cool solutions to help people out.
Well, thank you both.
And thank you, John, for bringing him to my attention so we were able to help him out with a cool project.
You killed it, Ben. Thing rocked.
For this episode's challenge, we worked with John's Arcade to build a specialized joystick and button actuator that could be installed on a wide variety of arcade games, allowing one-handed play. It took a lot of tweaking, but we finally got it to work using a beefy cordless drill battery. I'm pretty happy with how it turned out, and it was fun working out the challenges along the way, like how to keep it from bouncing. As for what I would have done differently, I'd prefer a smaller battery pack, and the button actuators themselves could probably be a little smaller as well. What approach would you have taken with this project? Have you ever modified an arcade machine or gaming system for specialized use? Let us know on the Element 14 community, where you can also keep track of our upcoming episodes, builds, and special events. We'll see you next time. 9! Ah! Then he goes through a propeller or something. I think they scanned Christopher Lee when they made that movie because they thought he would die. So if they had to finish him with a computer, they could. And he lived another 15 years. Because he's awesome.
Real artists don't work for money.
Haha, why would my measurements ever be wrong? Don't answer that. Why build one when you can make 2 for twice the price? The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.